Hi, welcome to solveandgo.com. This is the second video in a series of videos giving solutions to the MAT186 final exam from 2005. This is question 2. This is about the area of a regions bounded by some graph. So the question is the area bounded of the region bounded by the two curves f of x equals x cubed and g of x equals 2x cubed plus 2x squared minus 3x is given by question mark. Okay, and if you have the test here, you can see the answers are all given in the form of integrals. So you don't actually have to calculate it, but you have to set up the appropriate integral. Okay, so the first thing to do is to actually define this region. It's bounded by these two curves at their intersection points. So the intersection of f and g we can get by setting them equal to each other. So we get x cubed equals 2x cubed plus 2x squared minus 3x. Subtracting x cubed from both sides, we get 0 equals x cubed plus 2x squared minus 3x. Okay, and we can factor this, I'll do that down here, as x times, it's going to be x plus 3 and x minus 1. Okay, so the intersection of f and g, you can see from this factorization here, is given by 3 points. Well, there are 3 points of intersection. So we have x equals 0, x equals negative 3, and x equals 1. Okay, so now let me erase what we have here and remind you of the curves. We have f of x is x cubed, g of x is 2x cubed plus 2x squared minus 3x, and the intersection points are at, so I'll write them in increasing order, negative 3, 0, and 1. Okay, so we need to get the area between the two curves in two given regions. So what we have here, so we have an intersection point at negative 3, another at 0, and another at 1. So we're getting the region bound by these two curves between negative 3 and 0, and also between 0 and 1. Okay, so let me draw a picture of what something like this might mean. This won't end up being the picture, but it's this type of thing. So say this was f. Okay, this might be g. So we know they intersect at 0 and 1. So we need to get the area of these two regions here. Okay, so again, f and g don't necessarily look like this, but this is the idea. So for instance, this is, I can't remember which way I call them, it doesn't matter. If this is f and this is g, well then, for instance, on this interval from negative 3, they don't quite intersect at 0 here, but okay, just giving a general picture. So on this region here, which I'll label 1, okay, we see that f is smaller than g, so you'd want the integral of g minus f on 1. And on region 2, you'd want the integral of f minus g. Okay, so we have to figure out which function is bigger than which on the appropriate interval. So one from negative 3 to 0, and the other from 0 to 1 in our case. Okay, so to see which one is bigger, we'll just take test points on the given intervals and compare the two values, one at f and one at g. So let's take, for instance, -1 here as a test point, and let's take a half here as a test point. Okay, so -1 is in the interval from -3 to 0, and on this interval, we can test which function is bigger by testing at -1. So f of -1 is -1 cubed, which is -1, and g of -1 is 2 times -1 plus 2 plus 3. Okay, so this ends up being 5 minus 2 is 3. Make sure I did that correctly. I did. Okay, so g at -1 is 3, and f at -1 is -1. So on this interval, g is bigger than f, bigger than or equal to f on the interval from -3 to 0. Okay, so we'll take g minus f on that interval. Okay, so just remember that. Maybe I'll write it down here for us. So we have g of x is bigger than or equal to f of x on the interval from -3 to 0. Okay, next we want to test the interval from 0 to 1, so we chose a half, if you remember, as the test point. So this is in this interval, and so on this interval, we're going to see which function is bigger than which. We take f of 1/2, which is 1/2 cubed, which is 1 over 8. And then g of 1/2 ends up being 2 times 1 over 8 plus 2 times 1 over 4 minus 3 over 2, which ends up being, if you calculate it, 3 over 4. Okay, so on this interval, sorry, there should be a negative sign here. It's -3 over 4. Okay, so it's -3 over 4, which means f of x is bigger than g of x on the interval from 0 to 1. Okay, so let me add that to our list here. So we have f of x is bigger than g of x on the interval from 0 to 1. And so the integral we need is, okay, so from -3 to 0, we have g minus f. And on the interval from 0 to 1, we have f minus g. And that's the answer, which corresponds to answer choice D on the exam.